Yeah, hi, welcome to VLSI Simplified YouTube channel. Uh, so, as a part of this 30 days Verilog lecture series, so we completed with 10 days of this, and we are in day 11. So, in day 11, we are going to, I will explain you the code related to shift register. Okay. So, what is the shift register? Mainly, I will concentrate on serial and serial out. So shift registers are actually used for loading the data and shifting the data. So mainly we will design the shift registers by using D flip-flop. There are four types of shift registers are there. One is SISO, serial in serial out. Okay, SIPO, serial in parallel out. PISO, parallel in serial out, and parallel in PIPO, parallel in parallel out. Okay. So in this day 11, I will explain you the code related to serial in serial out. Okay, and how to execute that code in EDA Playground and Xilinx Vivado, Quartus Prime, and Model Sim. Okay, so let's we go. Okay, so this is the code related uh, to execute in EDA Playground. Okay, see here. CISO means serial in serial out. Okay, so whatever if you take 4 bits of data. So the data we can shift left or shift right. Okay. So here we are discussing shift data from the right. So when you are shifting the data from the right, we need to insert you need to insert the data from the left. Okay. So this is the code. Tick time scale 1 nanosecond by 1 picosecond. So delay is 1 nanosecond and precision is 1 picosecond. Module. What is my module name? That is CISO. Okay. Serial in serial out. Okay. CISO serial in serial out. CISO shift register and I need to give the clock. Okay, so you have input clock and one input is serial in, that is 1 bit only, and output is serial out. This is also 1 bit. Okay, so you are declaring one temporary register, that is reg 3 down to 0. So by using a vector, that is a 4-bit register, 3 down to 0, shift underscore register. Okay, I'm declaring 4-bit register. And after that, I'm writing the code always at the rate passage of clock begin. Okay. So during the passage of clock, so first shift. So in this 0th bit, okay. So serial in will be loaded. Okay. Shift register of 0 is non-blocking with the what serial underscore in. Okay. Shift underscore register of 1 is the serial underscore register of 0. Okay. Shift underscore register of 2. So see, shift underscore register of 1 will be assigned to shift underscore register of 2. Okay. Shift underscore register of 3 is non-blocking with shift underscore register of 2. Okay. So that means every time this will be shifted. Okay. So serial in will be assigned to shift register of 0 and shift register of 0 is assigned to shift register of 1 and shift register of 1 is allocated to shift register of 2 and shift register of 2 is allocated to shift register of 3. Okay. So this is actually right shift. Okay. Where you are getting the data, that is 1 bit of data. So I'm using as the serial out is what here I'm not declared any wire or ridge. By default, it will take as wide data type only. Okay. I'm using the serial out shift register outside the procedural block. Okay. So this is actually my procedural block and I'm using the behavioral modeling style and I'm using the serial out outside the procedural block. So for that, I need to use a continuous assignment statement assign serial out. Serial out equal to what? Shift register of 3. So this 1 bit of data will be assigned to what? Shift register of 3. End module. Okay. So one bit will be coming. Okay. Coming to the shift register of 3. One more method is by using concatenation operation also we can do this CISO operation. Okay, CISO. That is a different logic. This is simple and easy to remember this code. Coming to the test bench. So tick time scale 1 nanosecond by 1 picosecond module test bench. Okay. So module test bench in order to remember. So I'll give the name for this is let us take CISO. mm, CISO underscore test bench. Okay. CISO underscore test bench. So we need to declare the internal variables of the test bench. Okay. So what are the internal variables? As per port role connections, we need to declare clock and serial in with reg data type and serial out with wide data type. And I need to instantiate my design. How to instantiate? So design name. What is my design name? CISO underscore shift register. This is my design name. Okay, CISO underscore shift register followed by the instance name, that is DUT, and I'm using connection by name. Okay, connection by name means whatever the variables outside the bracket are design inputs and outputs. Whatever the variables inside the bracket are test bench variables. Okay, so this is the instantiation connection by name. You are instantiating your design. You should instantiate your design in the test bench. Okay, so you can instantiate connection by name, or you can instantiate connection by position also. So that is instantiation by position with order list. Mostly that will be not preferred in industry. They are preferring this connection by name only. Okay, so instantiation connection by name. Okay, always begin. I need to generate the clock. Okay, how to generate the clock? I'm using always begin hash 5 clock equal to not of clock end. Okay, so every time 5 time units, 5 nanoseconds, clock should be 0, and after that again 5 time units, clock should be 1. Okay, so we are generating the clock with how much nanoseconds? 10 nanoseconds. Okay. And after that, you need to initialize the reg variables. For that, I'm writing initial begin. So what are the reg variables? Clock and serial in. Okay. So these are the steps we need to follow when you are writing the test bench. First, you need to uh, declare the internal variables. You need to instantiate your design, clock generation, and initialize the reg variables. After that, give the test vector or give the stimulus. Okay. So I'm initializing the reg variables. What are the reg variables? Clock equal to 0 and serial in equal to 0. Okay. And next dollar display. If I want to display the values, okay, time, serial in, serial out. Dollar monitor means if there any change in these variables. Okay, so I'm using a format specifier percentage D, and this is actually backslash T tab. Okay, tab means more than the space. Okay, that we can use in this double quotes. Okay, percentage D and backslash T percentage D, dollar time, serial in, serial out. Okay, what value I want to insert, and shift. First, I need to load the data. Okay, serial in I am giving as 1. After 10 time minutes, serial in I am giving as 0. And after 10 time minutes, I am giving as the 1. After 10 time minutes, I am giving as 0. Okay, 1010. Okay, and dollar finish end and end module. Okay, so this is the test bench. And when you want to execute in EDA playground, two more uh, commands we need to add. What are those commands? The same program only, whatever I explained. Here you see. So here, so in this, I can use SIPO also. SIPO means so here passage of clock. Yeah, shift register. This is parallel out actually. Actually, this is parallel out. Okay. First we'll see CISO. Okay. After that, I will tell you the SIPO. So here, one second. SIPO. Yeah. Okay. Dollar monitor. Okay. We'll see the CISO program in EDA playground. Shift register. In this, we are covering the CISO as well as SIPO. Okay. This is CISO. Okay. CISO program. I will see in the EDA playground. So this is my RTL code. Copy this and go to EDA playground. Here you paste and next coming to the test bench. So this is my test bench. Copy this and your paste. Okay. Uh, so select tools and eliminators, Aldec Rivera, and save and run. So loading of data is happening here. After that, shifting is happening. Okay. This one I want to check in the EDA playground, Vivado. Okay. First, go to File, Project, New, Next. My project name is, I'm giving the project name as Serial uh, or Shift Registers. Okay. Shift underscore registers. Okay. Shift underscore register. And we are in day day 10, no? Sorry, day 11. We are in day 11. So select the path of this project location. Next, this is my RTL project. And so give the file name as module name. Okay, what is my module name? CISO shift register. Copy this and paste. Choose the location. So shift register. Select. OK. Next. This is optional only. Next. So this is the selecting of FPGA board device and finish. Yeah, module name also I want to give the same name. So this is my CISO. Just copy this Verilog code and here you paste, save. Coming to the test bench, we need to add in the simulation sources. Okay, select the simulation sources, add or create simulation sources, create the module name. Okay, so let us take this is CISO test bench. Copy and here you paste. Choose the location, shift register, select, OK, finish. OK, yes, my test bench is created. See here, this is a test bench. OK, again, copy this code, copy this code, paste here, save. One second, end module is missing. No, end module. Yeah, so my design is instantiated in the test bench. So what is my design name? CISO shift register and the instance name is DUT. Okay, so this is instantiated. So if you want to see the circuit, so how the Vivado is converting your code into gate level netlist, so go to RTL analysis, elaborate the design. Yeah. So it is converting in terms of D flip-flops. How many D flip-flops are required? For 4-bit shift register, you need 4 D flip-flops. Okay. Serial in data is giving like this. Okay. Serial in data, 1 bit we are giving to the first flip-flop and first loading of data will happens. So this is a shift register 3 down to 0. Okay. So 4D flip-flops will be there and clock will be given, and like this feedback will be there. Okay. So like this the tool is converting our RTL code into gate level netlist. Okay. Coming to the simulation. So in the simulation, run the behavioral simulation. So you can go to here, fit to page. Here we are, one second, shift register serial. Here till here, what is happening? So I need to give some more cases in the. Actually, it will take 7 clock cycles to get the serial out data. So here loading of data is happening. Okay. So so actually during this passage, I am giving serial in equal to 1. Okay. And after that during this passage, serial in equal to 0. Okay. Again during this passage, serial in equal to 1. Okay. So till here loading of data is 1010 we gave, no? So 1010, and here 1 bit of data will be coming out. Okay. So 1010. Okay. 0 will be like that coming out. So here what we need to do here uh, in this test bench, I need to give, suppose I need to check whether the data is coming or not. So 1010, first 0 will come like that. Okay. So next one will come at the uh, in the shift register 3. Okay, I need to check in the where here serial out. I need to check in the serial out. Okay, serial out equal to shift register 3. So whatever the value of shift register 3 is there, that is coming. That means 1010. Okay, so that value is coming at the serial out. Okay, here it is coming. Okay, so three more clock pulses if we are giving, so we are getting 4 bits of data to serial out. Okay, so this is about the CISO shift register. Yeah, here one second, one more process is there. Yeah, this is a shift register. So this we can execute in Vivado as well as quarters prime also. For the quarters prime, so what you need to do, you need to create like 3 folders. Okay, so one is so in the shift register, I created 3 folders. One is RTL, SIM, and TB. Okay. So whatever the RTL related code is there, I need to write in the RTL file. And next test bench related, I need to write in the test bench TB. Okay. And the project I need to store in the this SIM folder. Okay. Whether you are using this quarter prime or model SIM. Okay. So if you go for the quarters prime, so if you see this, so go to this new project wizard and check the location. Means choose the location where you want to store the your project. Let us take mm, so 30 days. We are in 11 day 11, no? So day 11 sim folder. I am creating this. Okay, and so what is my project name? Give the module name only. Okay, give the module name as project name. Copy this and you paste. Next, this is empty project only. So we need to upload the RTL file. Okay. So, so in day 11, RTL upload this file. Okay. This file has been uploaded. Okay. And next, select the any FPGA board. Okay. Next, and finish. Now my RTL file is added here. Okay. And go to this compile design analysis and synthesis start. Yeah, I got zero errors. Go to analysis and synthesis, netlist viewer, right click RTL viewer. Whatever we seen in the Vivado, same like that it is showing in the uh, Quartus Prime. Okay. And coming to the model sim. So for the model sim, go to file, project. Mm, so I'm creating new project. So I want to close this. Let us give the project name. Project name, give this module name only. So copy this and here you paste. Choose the location. We are in day 9, day 11. No? So day 11. So I created three folders, that is RTL, SIM and TB. So you need to select this path, SIM. Okay, okay, and add the existing files, RTL file, SIM file, and TB file. Okay, so this is my RTL file. Add the existing file and go to this test bench. This is my TB file. Open, OK, and close. Okay. So next, what you need to do? Right click, compile selected. Okay. After, if you are getting tick mark, go to library, go to work, test bench. You need to simulate. Okay. Test bench you need to simulate. And next, what you need to do? Go to this CISO test bench, add wave, DE2 test bench, add wave. So you need to group here. Okay. Test bench files and DE2 files. So here, if you see, these are my test bench files. Okay. Right click, group. So what are these files? Test bench files. Okay. And these are my DUT files, group DUT. Okay. Okay. Go to run here. Run all. No. Okay. So you will get the waveform. So this one you expand. Zoom full. So here what is happening? Every clock cycle, loading of data is happening. Okay. So loading of data is happening, and after that shifting is happening. Okay. Every clock edge, every passage, first here one is loaded. One bit will be loaded. Next zero is will be loaded. Next one will be loaded. Next zero will be loaded. Okay. So loading of data will happens. Okay. Here you got. So 1010. Okay. Shift register. Okay. Every time one bit will be shifted, and that is coming to the shift register. Okay. 1010. Here what is happening? One is shifted. Again 10 is coming and 101 is coming. One bit is coming. At last what you are getting? 1010 you are getting. Okay. This is how we can analyze the CISO, shift register, serial in, serial out. Okay. And next, coming to serial in, next is we are in day 11. No? One second. So here if you see, mm, next we are going with yeah. This is a test bench. Okay. We are going with SIPO. Okay. Serial in, parallel out. Okay. What is this? Serial in, parallel out. Serial in, parallel out. The only change is the data will be loaded serially, and 4 bits of data is coming out. Okay, at a time, at the same clock pulse, 4 bits of data is coming out. Okay, so data will be loaded serially, and we are taking the data 4 bits of data at a time. Okay, so loading will take 4 clock cycles. At same clock cycle, we are taking the 4 bits of data. It will take 4 clock cycles. Okay, so this is the code module SIPO shift register. So I need to declare input clock reset. Okay, here I am using reset. Okay, so serial in. Okay, serial in. These are the input signals. Those are declared with y data type. Output. So outputs are 4 bits of data. No? So I am declaring with a vector. Okay, 3 down to 0 parallel out. Output 3 down to 0 parallel out. Reg 3 down to 0 shift register. So this is actually we are using asynchronous active high reset. Okay. So if it is asynchronous active high reset, so here this should be what in the sensitivity list we need to declare passage of reset. We need to declare what passage of reset. Okay. If it is asynchronous negative edge reset means we need to declare neg edge of reset. And here if not of reset, if reset equal to 0, then it should be resetted. Here, here it is passage of reset. That's why if reset equal to 1, then the output of the shift registers becomes 0. Okay. So here I am declaring the one temporary register. Okay. That is what shift register. Okay. So I am declaring with reg data type 3 down to 0 shift register. So this shift register I am going to use in the procedural block. Okay. This is behavioral modeling style. I'm using in where procedural block. That's why I'm declaring with reg data type. Okay. So at last, I'm using that whatever the content of the shift register, I'm assigning to parallel out. So that's why here I'm not declaring with reg data type. I'm declaring with the y data type only. So I'm using continuous assignment statement. That's why. So I'm declaring with y data type. Okay. Now this is the sensitivity list. Always at the rate passage of clock or passage of reset. Begin if reset. If reset equal to 1. Okay. Begin. Shift register should be non-blocking with what? 4-tick binary, all zeros. Okay. And else begin. So loading of data will happen. Okay. So this is actually loading and shifting also. Okay. Shifting will be happening. Serial in shift register 0. Shift register 0, shift register 1. Shift register 1 will be allocated to shift register 2. Shift register 2 is allocated to shift register 3. At last, parallel out. So you need to get the 4 bits of data at a time, no? So that is a parallel out is 4 bit and shift register is also 4 bit. Okay, whatever the content of the shift register that should be coming to parallel out. So you need to use what type of statement? Continuous assignment statement. Okay, end module. Okay, so this is the code related to the SIPO. Okay, SIPO and coming to the test bench. So tick time scale 1 nanosecond by 1 picosecond. Module SIPO. Okay, SIPO shift register TB. Okay, as the expense does not consist of any inputs and outputs, so we are declaring like this only. Okay, so but it have the variables. Okay, test bench variables. So we need to declare the test bench variables. Clock reset and serial in. I'm declaring with the reg data type and parallel out. That is 4 bits of data. 3 down to 0, I'm declaring with y data type and declaring the internal variables of the test bench. And next, I need to instantiate my design in the test bench. Okay. So it should match design name. What is my design name? SIPO, shift register, instance name, DUT, and connection by name. So connection by name means whatever the variables outside the bracket are design inputs and outputs. Whatever the variables inside the bracket, those are test bench variables. Okay. And you need to generate the clock. Always begin hash 5 clock equal to not of clock end. Okay. So I'm generating the clock with the clock time period of 10 nanosecond. So always it is off for 5 nanoseconds and it is on for 5 nanoseconds. Okay. So continuously we need to generate the clock. That's why I'm using always. Okay. Initial begin. So I need to like clear the reg variables. Okay. For clearing the reg variables, I'm giving what are the reg variables? Clock, reset, and serial in. No. So this clock equal to 0, reset equal to 0, and serial in equal to 0. I want to display the either it may be log folder, or it may be TCL console, or it can be transcript window. Okay, if you want to display, you need to add these commands. Okay, dollar display a time, and backslash t is a tab, serial in tab, and parallel out. Okay, so I'm displaying this dollar monitor. So these are in format specifier percentage d tab percentage d tab percentage d. Percentage d means I want to display in terms of decimal. Okay, it's a format specifier, and dollar time serial in and parallel out. Okay, so if there any change in this either variables, then it will display. That is the dollar monitor system task will do. And next, what you need to do, you need to give the stimulus. Okay, serial in equal to same value I'm giving 1. After 10 time minutes, I'm giving 0. After 10 time minutes, I'm giving 1. After 10 time minutes, I'm giving 0. Dollar finish end and end model. Okay. So this one first I will execute in EDA playground, and I will show you. After that Vivado, and after that Quartus Prime and model sim. Okay. Just I'm copying this code. Go to EDA playground, new, paste this, and next come into the test bench, copy this code, paste here, save. Yeah, we need to select the Aldegree Rivera, save, run. The shifting is happening, and we are getting 4 bits of data at a time here. Okay, so that is coming in the in this EDA playground, and coming to Vivado, here close the simulation and close this elaboration design. Go to design source, add the design source, create the design source. Okay, so give the module name. What is my module name? Sipo register, copy. Here you paste, choose the location, shift register. Okay, finish. Okay, yes. So this is my shift register design file. Okay, so copy the Sipo, paste, and for test bench, go to simulation sources, add the simulation sources, create the simulation sources, give the test bench file, copy this, choose the location, shift register, okay, finish, okay, yes. So this is a Sipo TB. So this test bench file is there, no? Just you copy this, and you paste in this, save. My design is instantiated in the test bench. Okay. So if you want to see the design and simulation, so what you need to do, click on this, right click, and you need to make this set as top module. Previously CISO is the top module, no? Now you need to make CIPO as the top module. And the simulation part also, right click, set as top module. Now if I want to design, see the design, Go to RTL analysis, open elaborated design. So like this, serial in is 1 bit of data, and parallel out is 4 bit of data. Clock is coming and reset is also. So as this is asynchronous active high reset, so this is reset is given to clear signal. So when reset is 1, so all the clears will be activated, and independent of clock and input, it will force the output to what? 0. Okay. So actually we have two types of asynchronous signals are there. One is clear and preset. Okay. So when preset is activated, independent of clock, it will force the output to 1. When clear is activated, independent of clock, it will force the output to 0. Okay. So like this, we can see uh, uh, the netlist schematic. And for the simulation, go to simulation, run behavioral simulation. So you can see in the TCL console also. So this is so we are getting it the parallel out. We are getting the waveform also. See here. So at last, so loading of data is happening first. Okay, loading and shifting is happening. Okay, till here it is don't care only. Okay. So, so at which clock pulse you are getting? So first clock pulse, okay, first clock pulse 1 is coming, and second clock pulse serial in 0 is coming, and third clock pulse 1 is coming, and at fourth clock pulse, so 0 is coming. Parallelly, you are taking out the data at a time. Okay, so just you can expand here, or otherwise right click radix. I'm giving binary. So So if you see here, so 1 is coming over during first clock pulse, and 1 0 next bit is coming, and third bit is coming 1 0 1. So here the fourth bit is coming. Parallelly, you are taking out the data in the parallel out. So 1 0 1 0 1 0 1 0. So like this, it is happening the shifting as well as parallel out. So you are taking out the data at a time. So it will require. So by the simulation also we came to understand that it requires 4 clock pulses to get 4 bits of data at the parallel out. Okay. Yes. This is about the SIPO. And coming to execute in quarter prime and EDA playground, what I need to do means this code is there, no? So I'm copying this. Here I need to create, so I need to, here I'm opening GVim, paste here, and so copy this module name, go to file, save, and in the day 11 I created 3 folders, no? RTL, SIM, and TB. So in the RTL, I need to paste this, okay, I need to create this, okay, an RTL file, okay, and next, same testbench file, so testbench file, copy, and here open GVim, paste here, and FIPO, shift register TB, copy this file, save, and I created TB file now. Here you need to save the TB file with the module name, okay. So like this you need to do. Okay. In the text, so in the RTL file, whatever the RTL related codes are there, we need to save. And in the TB file, test bench related codes we need to save. And project folder, the path you need to give as sim. Okay. In Quartus Prime as well as model sim. Okay. So I created. First open the Quartus Prime. So I'm closing this file, new project wizard. So I want to close this. Next. So path is same only. So whatever the previous path I gave, same path I gave. So you need to give the project name, no? So I'm giving the same module name only. Copy this and here you paste, copy this, here you paste, next, yeah, next, add the RTL file, okay, go to RTL, SIPO, okay, upload the RTL file, next, and select any FPGA family, next, next, finish. So go to compile design. In the compile design, RTL analysis and synthesis is there, no? Right click, start. I'm getting one error. Mm, 1 second. This file I'm using. Mm, copy, and in the TB file I need to paste. SIPO, select all, paste. Here instantiation for CISO is not required. We are seeing the SIPO now. So yeah, save this. Once again I'm doing. So quarter prime. Here once again I'm creating new project wizard. Next. So what is my module name? This is my TB. SIPO. Okay. Copy this and paste. Next. Next. Add the RTL file. SIPO. Open. Next. Select the FPGA family. Next. Next. Finish. Go to analysis and synthesis. Start. Yeah, zero errors I got. Go to this analysis, netlist viewer, RTL viewer, open. I'm getting this. Okay, so like this I can get. And coming to the model sim, just you give the command quit sim, quit hyphen sim. Okay, it will come out from the simulation. So file, new project. I want to close this current project. So what is my project name? Tipo, no? Copy this and paste the project name. Choose the location is same only, day 11 we are in. Add the existing files. So add the RTL file. Okay, SIPO. Okay. Add the TB file. SIPO. Okay. Close. Select these two. Right click and next compile selected. Compile selected. Okay. Next go to library and SIPO. Okay. SIPO shift register. This is actually my test bench. Okay. Right click and simulate. And next go to run all. No. Okay. And now you see. So in the transcript window, first shifting is happening. Next parallel out is happening. Okay. So 1010 is coming. Okay, like this. Okay. And here you see. So if you want to load 1101, here you are getting. Okay. You can see in the waveform also. So one second. Uh, so here this is the code actually. Next for the waveform in the text bench, right click add wave. Okay. So this is here it will be added. Okay. And DUT add wave. Here text bench files. So test bench. Okay. Group this TB file and next you group this, right click test DUT file. Okay. Okay. And expand this. Just zoom fill. One second. Mm, run all. Yeah, shifting and parallel out is happening. Okay. So can't see in the simulation part, but in the transcript window, I can see here. So in the transcript window, here you see. So that means here shifting is happening. Here you see up to 35 shifting parallelly parallel out data is also happening. Okay. So 4 clock cycles it will take 1010. After that, so you are inserting the data here, and here parallel data is happening. Okay. So like this we can do the serial in parallel out. Okay. So today we discussed the serial in serial out and serial in parallel out. Okay. So in the next session, like day 12, two more shift registers are there. One is parallel in serial out and parallel in parallel out, that we'll discuss. Okay. Thank you.